Okay, so in this video I'll be explaining a very important skill in chemistry, okay, which is writing and balancing equations. Okay, I call it topic 0 because it is not an actual topic on its own, but it is something that will permeate into every other topic that you will learn subsequently. So there are certain rules that I would like you to be able to understand, okay, as fundamental rules, okay, in terms of how do you actually name chemical substances, right? Basically, every chemical has a name, and you must be able to name it properly so that when it comes to writing the chemical formula, you won't mix it up with some other chemical. So the rules are, okay, firstly, we are actually looking at two different types of chemical substances, okay. The first type will be ionic compounds, okay, containing a metal and a non-metal, right? So basically we're talking about ionic compounds, okay. Later on in the subsequent topics, you will learn more about what exactly are ionic compounds, okay. But for now, just understand that ionic compounds basically contain a metal and a non-metal, right? Chemically joined together, right? So the rules for naming an ionic compound containing a metal and a non-metal will be that the chemical name starts with the metal, okay, and then it's followed by the non-metal, okay. So and the non-metal, okay, the name of the non-metal will actually end with IDE. Alright, so okay, here I just included an extra note whereby hydrogen, for example, can be metallic or non-metallic. Okay, so the metallic name will just be its original name, which is hydrogen. Okay, this is the ionic form H+. Okay, ionic substances basically, or ionic compounds basically consist of elements with a charge, right? So here you have a plus +1 charge. Okay, that's why it is part of an ionic compound, right? And hydrogen in its non-metallic form, okay, because a non-metal must end with IDE, okay, it will be actually called hydride, right? So you keep the front portion, which is hyd, and you replace the OGEN with a IDE, right? So if it's in a non-metallic form, okay, you call it a hydride, right? And usually non-metals will have a negative charge, okay, in the ionic compound. So in the case of hydrogen, it will have a -1 charge, okay, if it's in a non-metallic form, okay. But the rule is the same. You call it a hydride, right? Replace the OGEN with IDE. So here I'll just provide an example, okay. So here you have the ionic compound called calcium fluoride, okay. The chemical formula is CaF2, whereby Ca is calcium, okay, and fluorine, okay, is actually the F, okay. So when they chemically join together, they'll form an ionic compound called calcium fluoride, okay, consisting of calcium, okay, which is Ca2+, the metal, and fluorine, okay, which is F-, which is the non-metal. The non-metal metal will have a positive charge in the ionic compound, whereas the non-metal will have a negative charge, okay. And take note that the name of the metal remains the same, okay, which is calcium remains the same as calcium, but fluorine you actually end with IDE, so fluorine, which is the non-metal, becomes a fluoride. Okay, so that's just the rules, okay, for naming an ionic compound containing a metal and a non-metal, right? Just keep the metal as the same name. The non-metal you end with a IDE. So in this case, fluorine, you end with a IDE, so it becomes fluoride. And of course, you always start with naming the metal first. So you start with calcium first, right? Okay, now we'll move on to ionic compounds containing a polyatomic ion. Okay, so what is a polyatomic ion? Okay, so here I provided a table, okay, giving you a list of common polyatomic ions, right? So polyatomic ions basically consist of is an ion that consists of several elements elements, okay, several atoms of elements. So here, for example, ammonium, you have it's not just nitrogen or hydrogen, but it consists of one nitrogen atom over here, right, and 4 hydrogen atoms. So it's polyatomic because it consists of more than one atoms, okay, and it's an ion because it has a positive 1 charge overall, right. So this table will show you some examples of polyatomic ions. So how do you name an ionic compound containing a polyatomic ion? Okay, so containing one of all these ions, okay, will be that same thing as the previous case, okay. It will start with the metal or the positive polyatomic ion, okay, followed by the non-metal or the negative. So it's actually the same in terms of the order, whereby you name the metal first, okay. The metal usually will be the positive, will have a positive charge. So in this case, it will be a positive polyatomic ion, okay. And then you followed by the non-metal, and non-metal, since they are usually negative, so you name the negative polyatomic ion subsequently, okay, after the positive polyatomic ion. And of course, once again, if there's a non-metal, it ends with a IDE, right? So it's very similar to what I have explained previously. So just to give you 2 examples, okay, so if an ionic compound, okay, between ammonium, okay, which in this case is NH4+, that's the formula, okay, as given in the table, right. This is a polyatomic ion because it consists of several atoms, 1 nitrogen atom and 4 hydrogen atoms. It's an ion because there's a positive 1 charge, so it's a positive polyatomic ion, okay. And you want to chemically join it with chlorine to form an ionic compound, okay. So in this case, the chlorine is a non-metal, okay, so it will end with a IDE, chloride, okay, whereas the metal or the positive polyatomic ion will remain the same, okay, and it's at the front, right. So you call it ammonium chloride. So another example will be between sodium, okay, which is just a regular metal, and sulfate, okay, which is a negative polyatomic ion, okay. Sulfate is a polyatomic ion because it is SO4 2-, okay, it's over here in the table, SO4 2-, right. This is the sulfate ion, okay. It's polyatomic because it has several atoms, okay, 1 sulfur atom, okay, and 4 oxygen atoms. And it's an ion because it has a negative 2 charge, right. So in this case, the sodium, the metal, will be at the front, but it doesn't change, the name doesn't change, so sodium remains as sodium. But in this case, because the what you have behind is a negative polyatomic ion, okay, so what you actually name it will be, you call it a sulfate ion. Okay, so it is not a non-metal. So in this case, the previous example of ammonium chloride, chlorine is a non-metal, so you actually have to end it with IDE, okay, same as the previous rules that I've talked about. But in this case of sodium sulfate, the sulfate is not a non-metal, but it's a negative polyatomic ion, okay, so we will name it as given in the table above, okay, which is a sulfate ion. Okay, so these are the names of the in this table I've also provided the names of the polyatomic ions, okay, as they are used in an ionic compound. Alright, so you just call the sulfate ion a sulfate. Alright, okay, that's the name of the polyatomic ion in an ionic compound. Okay, so now we'll go on to something called valency, right? Valency actually is, I'll explain further what exactly is valency, okay? But for now, I just need you to understand how do you actually determine the valency of elements, alright? So usually when you're talking about elements, okay, you will see that they are being classified in the periodic table. Okay, so periodic table basically has groups, okay, and periods, okay, but for the purposes of determining valency, okay, we are only concerned with the group number, right, which is the vertical columns in the periodic table, which goes from up to down, okay. So those elements that are in group 1, they will have a valency of 1, okay. So for example, lithium is in group 1, okay, sodium is also in group 1, potassium is in group 1, so they all have valency of 1, okay. For now, you just have to know that if they have a valency of 1, okay, they will actually just have the valency sort of represents the charge that they will tend to have, okay, when they actually combine with other elements to form an ionic compound, right? So if it has a valency of 1, okay, group 1 represents metals, okay, so all these are actually metals, okay, and if they have a valency of 1, these metals will all have a positive 1 charge, as you can see, right? It's a plus 1, plus 1, plus 1, right? We don't write the 1 here, okay, but when you have a single plus, know that it represents a plus 1 charge. So elements that have a valency of 1 will form an ion that has a positive 1 charge in an ionic compound, right? So lithium is Li plus, right? This represents a plus 1 charge. So group 2 will have valency of 2, so all these elements in group 2 will have a 2 plus charge. Group 3 will have valency of 3, so all these elements will have a 3 plus charge. And group 4 is slightly different, okay. They have these elements in group 4 will have a valency of 4. However, group 4 elements, okay, they usually have no charge. For example, carbon, for example, okay, because they form covalent bonds, which means that they actually share electrons, okay, and electrons are not transferred to or from them, okay. So they do not gain or lose any electrons. As a result, they do not gain the charge. Instead, they share electrons, okay. So there will be no charge, right? Okay, because they form covalent bonds instead of ionic bonds. Okay, so group 5 will have once again valency of 3, okay, because never mind, I'll just briefly explain okay, how these charges are actually formed. Okay, so when you have a metal, okay, in group 1, okay, these metals tend to lose 1 electron to form a stable octet structure. Okay, a stable octet structure refers to having for example 2 or 8 electrons in the outermost shell. So that will actually give them a stable electronic configuration, right? So when they actually lose 1 electron, because they have 1 extra electron, it is easy for them to lose this electron and achieve a stable octet structure. Okay, they have 1 electron in the outermost shell, so it's easy for them to lose this 1 outer electron in the outermost shell, okay, to form a stable octet structure. And in losing this 1 electron, they gain a plus 1 charge, right? So for group 5, there is a valency of 3, okay, because these elements tend to gain 3 electrons, okay, so they have 5 electrons in their outermost shell, okay, so they will tend to gain 3 electrons, okay, to form a stable octet structure. Okay, octet means there's 8 electrons in the outermost shell, so if they have 5, they will gain 3 electrons, okay, to form 8 electrons, and in gaining these 3 electrons, okay, they will acquire a negative 3 charge, okay, because electrons are negatively charged. So group 5 elements have a valency of 3, okay, because these elements will gain 3 electrons to form a stable octet structure, and by gaining 3 electrons, they will gain a negative 3 charge. Alright. And group 6, once again, okay, same thing. Okay, they will gain 2 electrons. Okay, so they will actually tend to have a negative 2 charge. Okay, and group 7, okay, elements, they will have a negative 1 charge, right? Because they will gain 1 electron, so 7 plus 1, you will get 8. Okay, so originally they have 7 electrons in the outermost shell. They will gain 1 electron, okay, to form 8 electrons. When you have 8 electrons in the outermost shell, it becomes stable. But in gaining this 1 electron, they will gain a overall -1 charge, right? So group 7 elements, they have a valency of 1, okay, because they have a -1 charge, okay, when they actually form ions. So if you don't really understand my explanations regarding the formation of ions, okay, the gaining of electrons and the losing of electrons, okay, that is okay, because I will cover this in the subsequent topics, right? But for now, just know that you can determine the valency of elements, okay, based on the groups that they are in. Okay, so group 1 has valency of 1, group 2 valency of 2, 3 valency of 3, 4 valency of 4, but group 5 has a valency of 3, okay, not 5, group 5 has a valency of 3 and not 5, right? It's 3. Group 6 has a valency of 2, and group 7 has a valency of 1, alright? Okay, another method to determine valency, okay, will be through Roman numbers, okay. This is more straightforward, okay. So for example, if I have copper 1, okay, if for example the name of the ion is called copper 1, I will automatically know that there is a this ion or this element has a valency of 1, right? Because it's given to me, right? Copper 1, right? So 1 tells me that it has a valency of 1, right? Lead 2 tells me that it has a valency of 2, okay? And chromium 3, for example, valency of 3, lead 4, valency of 4, chromium 6, okay, the 1 in front of the 5, okay? If it's before the 5, it represents 5 minus 1, so it's 4. If it's on the right hand side of the V, okay, V represents 5, it means 5 plus 1, so chromium 6, right, means that it has a valency of 6. Okay, so this is quite straightforward. Sometimes we can also just straight away determine valency, okay, based on the charge of the polyatomic ions, right? So just now within the table above, okay, I've given you a list of common polyatomic ions. You'll notice that they will all have sort of a plus or minus on the top right hand corner. This represents the overall charge of the polyatomic ion. Okay, so for example, ammonium NH4 plus, it has an overall charge of +1. Okay, because it is a +1 charge, it is a charge of 1, therefore the valency is 1. Okay, for example, nitrate, nitrite, hydroxide, and manganate 7. Okay, you can see that they all have an overall charge of -1. Okay, so the charge is -1, and because it is a 1 charge, so charge of 1, so the valency is also 1. Right? So 2 minus, for example, carbonate has an overall 2 minus charge, sulfate 2 minus charge as well, sulfide also an overall 2 minus charge, so valency is 2. Right? Phosphate PO4 3 minus is 3 minus charge, so valency is 3. Okay, so some other common valency numbers will be zinc usually, okay, you just have to know and remember that zinc usually has a valency of 2, okay, and it will form a Zn2 plus ion, okay. Zinc is not found in group 2, okay, because it is one of the transition metals, okay, but you just have to know that most of the time it has a valency of 2 and it will form a 2 plus, an ion with a zinc ion with a 2 plus charge, right? Same thing for silver, okay, just got to know that its valency is 1, okay. Hydrogen, because it's not found in any group, so you can't use the rules above, right? Just know that hydrogen tends to form a valency of 1, okay, be it in the metallic form, as I have shown you above, or in the non-metallic form, okay, it will form ions with a valency of 1, right? Because it either forms a +1 charge or -1 charge. A charge of 1 means that it has a valency of 1.